right, welcome to technical session number 2, where we're going to be kind of introducing ourselves to the world of computers. So this course in general is designed to start people from zero, with little to minimal knowledge of computers, and then build them up to desktop support specialists. I was one of those people that had very little knowledge when I first stepped in. So if you're one of those people like, I just don't have enough experience, or I'm not really sure if I'm ready enough for this, you are. We're going to help you get to where you need to go. Our objectives for this particular technical session is going to be to give you a basic understanding how computers work, including the relationship between the hardware and the software. And then we're going to get into the end. We're going to be talking about some basic safety procedures and precautions you should take when you're utilizing tools, taking computers apart, and all that stuff to kind of protect both yourself and the computer. And with every technical session, we like to kind of associate them as well with behavior skills and mindsets that we are working towards. In this particular one, we like to talk about growth mindset and adaptability, as both are extremely important within the IT world, as adaptability, as the environment is constantly changing, evolving, and all of that, and we need to be able to adapt with it. And then growth mindset, understanding that your intelligence is not fixed. You can learn new things. You can develop new skills, which is why we're all here. So first basic starting point. What is a computer? Well, a more modern definition of it is an electronic device for storing and processing data, and according to the instructions given to it by a variable program. That could be an application, operating system, what have you. Basic types of computers that you may end up interacting with. Some of these may be familiar to you, some may not. Supercomputers. These are absolutely the fastest. They're way too big for personal use. Require a large facility to basically house them. So Big Blue is an example of this with IBM, car manufacturing. There's a variety of these out there. Supercomputers, massive, generally need warehousing, lots of cooling, and way too big for personal use. Mainframe, bit of a step down, tend to have lots of storage space, a bunch of input-output devices, and can connect across very large distances. A general example of this would be a server. Smaller computers can operate as servers, but that would not be a primary function, and they would not perform these tasks as well as systems designed specifically for it. Getting into some of the personal computer areas, you have the mini computer. It's a little bit faster than the microcomputer, holds more information, has more input-output devices, and example of these might be systems that you would connect a bunch of point-of-sale machines to. You might have noticed when you go to the grocery store now, they don't really have cash registers anymore. They have computers hooked up to cash drawers. So the days of the old school cash register are pretty much gone. So they use what are called thin clients to connect to a larger mini computer, which will control all of the little ones. And then finally, the microcomputer, which is what the majority of us use on a day-to-day basis, called micro because of the chip inside of it, not because of necessarily the size of the computer itself. These are becoming, or have been, much more affordable. IBM was one of the first ones to kind of put these out, and then you had what were called the IBM clones or compatibles, and then eventually Mac, Chrome, and then Linux and a bunch of others started putting some out as well. For the purposes of the exam, we kind of break things down into 3 general categories with regards to parts of a computer. You have the hardware, Easy way to remember this. This is all the physical stuff that you can touch. So this is your motherboard, your hard drives, RAM modules, NIC cards, CPUs. This is the hardware, keyboard, monitor, mouse, all the things you can physically touch and interact with. Then you have software. Software, these are the programming instructions that basically give us functionality or usefulness of the hardware that we're utilizing. A camera in and of itself is essentially useless. All it does is take in light. We have to take the light that has come in, turn it into some usable form so that we can actually interact with it. Microphones, same way. Keyboards. These things have to be able to communicate with each other in a way that we can interact with it. Otherwise, it's not very useful. So the software is what drives that. And examples of this would be your operating systems, programs, and applications that we use on a regular basis. Now, those two are kind of clear cut. Hardware, all the stuff you can touch. Software, the instructions that make it run. Well, there's a middle ground too, and that's firmware. And these are specific hardware chips that have software stored upon them. And they are there to execute very specific types of instructions. And it's considered firmware. Examples of this, which we will get into in a little bit, would be our BIOS chips and ROM storage. And ROM is short for read-only memory. BIOS is short for basic input-output system. Questions so far? Oh, all right. So different types of hardware, kind of get into, we got some computing components, you have various connectors, the ways we can hook all this stuff up together, from the ports on the back of your computer to the slots on the motherboard right here that we can add to, build upon, and create more functionality for our systems. And above and beyond the basic system we have, we add what are called peripherals. These peripherals are what really add the functionality. That would be like your webcam. It might be a microphone. It might be a keyboard, a mouse, a printer. There's a variety of peripherals, and we'll talk about these as we go along as well. So, firmware. Primarily used for startup instructions for low-level hardware. This is kind of like getting your motherboard up and running and basically telling the motherboard, here is where you go to find various things. Like, where's the operating system stored? The motherboard has to point the system to it upon startup. Is it on a flash drive? Is it on a hard drive? If you have multiple hard drives, which hard drive? Do you go out to the internet? Is it on an optical drive? Where do we go to look for our operating system? The BIOS would hold these instructions for us. Also, how much RAM is installed? How much storage do we have? So the RAM gives it, or the BIOS gives us these basic instructions to allow us to communicate with various devices, to kind of get the system up and running. The instructions on these don't necessarily change readily. It requires special utility to do it. And the term read-only memory is kind of a misnomer, because it used to be this never changed. But now we actually can update the BIOS and actually change what is written on the firmware. And this is called flashing the BIOS. We will get to this again, but they call it flashing the BIOS, and it tends to be one of the more risky things you're doing with your computer, because if anything happens during that process, a power surge, anything like that, your computer becomes a very expensive paperweight. So IT professionals will go through some pretty extensive links when they are flashing the BIOS on expensive equipment to make sure that there are no interruptions. All right, software, two basic flavors. You have your operating system, which is your overarching set of instructions. And then you have your applications and programs, which add functionality and perform useful tasks for us. So the operating system is essentially put in place to be able to control the hardware. So the BIOS tells you where to find it. The operating system gives you all these cool new ways to interact with it. And on top of the operating system, where we can run applications. So applications are much smaller forms of software or programs. Operating system is much larger, and it is an overarching system. Main examples of this would be like Chrome OS, Windows, Mac OS, Linux. We'll be touching on all four of these throughout the course. Although predominantly we'll be spending our time in Windows, as 85% of the market operates on that. Applications, they run on top of an operating system, and they tend to be written for specific operating systems. So just because a application or a program works on Windows does not mean it can run on a Mac. They have to be programmed for those specific operating systems. And we can use them either for entertainment or to perform useful tasks. Some examples: Microsoft Office, Apple iWork, various games, all that kind of fun stuff. Questions so far?
So we can say that hardware and software cannot work without firmware?
Well, the firmware, yeah, you can say that, yes. Because the firmware is going to be those basic instructions. Like once you put power into the system, it has to know where to look for stuff. And so the firmware is going to tell you, okay, we're getting these instructions. Okay, here's where you go to look for this. Here's where you go to look for that. And it kind of points everybody in the right direction. So all this stuff can be utilized. So every time you turn on your computer, the first thing that gets fired up is the BIOS. It performs a series of tests, and then it also tells the system where to go to look for things. All right. So much like all of us, computers have their own language. They don't utilize language the same way we do. They utilize basically a series of switches. And it is called machine language, otherwise known as binary. So this binary, in the view of the system, looks like either a 1 or a 0. So it's like a light switch, on or off, 1 or 0, at least until quantum computing becomes more common. And in this, there's some notations that we need to be readily aware of and quickly kind of remember. And a single piece of binary, so a single 1 or 0, is called a bit, B-I-T, a bit. That is a representation of a single 1 or 0. When we put 8 of these together, it's called a byte. So a byte is 8 bits. For a moment, I'm going to skip over the next one. A kilobyte is 1,024 bytes. Not 1,000. Some people will round it down just for ease of use, but in reality, it's 1,024 bytes is a kilobyte. Megabyte is 1,024 kilobytes. Gigabyte is 1,024 megabytes. Terabyte is 1,024 gigabytes. And so on, and so on, and so on. Now, with the use of hexadecimals, which we'll get into why we switched over to it and what it helps us with, they don't use the 8-bit bytes. They use what are called nibbles. A nibble is 4 bits. So bits 1, bytes 8, kilobytes 1024 bytes, megabyte 1024 kilobytes. And all of this so that we can create programs, letters, numbers, words, all that kind of fun stuff. And originally, they utilized something called an ASCII table, or ASCII, which is American Standard Code for Information Interchange. And it was basically laying out the binary to create letters, numbers, and symbols. It looks something like this. So I know what you're thinking. Do we have to memorize this to be able to be a help desk specialist? The answer is no. You kind of need to know what we mean or what we're talking about when we say an ASCII table, but no, you don't need to memorize this. We are going to do some work with binary, but this isn't it. So with ASCII table, we can get up to 128 characters. Seems like a lot, right? Except the problem starts coming in when you're talking about emojis, all the various symbols, the various languages and characters and all that stuff that we have to take into account. 128 does not go very far. This is not quite yet coding. Not quite yet. So they came up with a new system, which is called UTF-8. And this is the new updated version of it. And instead of 128 characters, UTF-8 has 1,112,000 characters. So that seems a lot more workable when you're talking about a variety of languages and characters and symbols and all that stuff that we interact with on a daily basis. Yes, that's the one we have to memorize. So that's the new updated version, is the UTF-8. All right, so how does the computer process this information? Like, what does it do? In a very, very high level basic sense, data comes in through an input device. So an input device could be a keyboard, it could be a mouse, it could be a NIC card, a webcam, a microphone. So it takes this and it is sent to the CPU memory so that the CPU can process that data based upon where the input is coming from and program it, you know, so that it can be used in a functional way. So like the webcam we talked about, what does the webcam do? It just takes in light. And once that light is taken in, it has to be organized and essentially established in a usable form so that we can see everybody's lovely faces as we come on, you know, to class every day. Once the CPU is finishing that data, it is presented through an output device. So a webcam will be presented through a monitor. Your microphone will be pushed out either through speakers or headphones. So it has to come out in a usable way. All right. Real quick, just a brief quiz. Go ahead and pause the recording there for a moment. So, as we were just talking about, inputs. So large variety here, just kind of giving you an understanding of what's going on. You got your keyboard, mouse, drive, scanners, digital cameras, microphones, modems, and a NIC. Anybody here know what a NIC is?
Network interface.
Yes. Excellent. Network interface card, NIC. Excellent. It's a monitor and input device.
Wouldn't that be an output?
Both ways.
Well, yeah.
Could be both, right? If it's a touch screen,
Touch screen.
right? So touch screen would be an input, right? Because you're able to interact with it and input information. So I want you to make a quick note of something. I want you to underline it, put arrows to it, highlight it, all that fun stuff. For the purposes of the A+, if they do not specifically state that it is a touch screen and they say monitor, assume it is not. So if they do not specifically state a touchscreen monitor, assume it is not. So it is only an output. So if they want you to think of it as a touchscreen, they will indicate that it is a touchscreen monitor. All right, our processing devices on our computer, that would be our CPU or central processing unit, our RAM, which is our short-term memory, our drives, which is our long-term storage, and our motherboard, which is kind of the connecting device that kind of is the nervous system or backbone of the entire computer. And then finally, our outputs. So this would be things like speakers, printers, monitors, modems, drives, and again, we see the NIC because it's both an input and an output, right? We receive information from the internet and we push information out to the internet. So, real quick. Iman, can you give me an example of an input?
Microphone.
Microphone, good. Let's see here. Shantae, can you give me an example of another one?
Sorry, I was on mute.
No worries.
A mouse or a drive.
Mouse. A drive, yeah, drive can be a good one. Excellent, thank you. Tamika, can you give me an example of an input?
A digital camera.
Digital camera, yeah. Very good. That could be an
Scanner.
example of an input. Who was that?
Ravensley, scanner.
Scanner, perfect. All good options.
Modem.
What was that, Gimanesh?
Modem.
Modem, perfect. Excellent. So these are all great examples. Mouse, see it in the chat. Great examples of inputs.
USB.
Yeah, USB. That could be an
Keyboard.
input. Keyboard. Kurt, can you give me an example of a processing unit? What would we use to process?
CPU,
CPU. Excellent.
RAM,
RAM. There we go. Is another one.
GPU.
GPU. Yes, that would be a processing.
motherboard,
Motherboard,
Motherboard. Miklet, what'd you say?
Drive.
drive,
Drive.
Yes, drive.
A video card.
Video card. There you go. Excellent. So these are processing units. What about outputs?
printer,
Printer,
projector,
monitor,
monitor,
Headphones.
display, headphones.
speakers,
Speakers. Trick question. Can a keyboard be an output?
NIC.
Nick, very good.
No. I
There
don't
are
think-
actually specialized keyboards for the visually impaired where they actually would have an output for Braille.
Oh, that's cool.
Oh, that's true.
So yes, depending, but that would be a specialized device. But yes,
A
there are
monitor.
cases where you would think something would be just an input or just an output, but there are versions that are both. What did you say, Ravensley?
A monitor.
Monitor. There you go. Output device. That also could be an input device.
CDRW,
CDRW. There you go. Input and output. Excellent. So
Are they-
all great examples. So we just have to understand the relationship of the things that we're interacting with as from the perspective of the computer. What is being used to process information? How is it receiving information? How is it, pushing that information out? So here it is kind of filled in just to kind of, give an idea, but we basically went through that in as well by ourselves. All right. Super fast question. How many kilobytes in a megabyte?
1024.
You just gave everybody the answer, Justin.
Oh,
Thanks, Justin. You know, I was about to say it out loud, and I was
This
like, wait.
should be
hold on.
100%. There should be nobody who misses this one.
I answered before Justin. I just want to put that out there.
Is there a link to this questions? I can't see it.
If you're in the link, the main link, it should be coming up because you will follow along. If you're in the student paste, it does not follow along with what I do.
I can't see it either.
All right, so here's the link. You click it on in chat. If you're transferring over to the Zoom channel, then you're not seeing it. So you should be able to see it on your individual screen. So let me I'll go ahead and share it now, I guess. Thanks to the heroic efforts of Justin, we had 100% on that quiz. All right. So now that we've kind of talked about some inputs, outputs, just basically starting to introduce ourselves to the components and all that kind of fun stuff, we got to talk a little bit about electricity. So, and be able to protect ourselves, not just ourselves, but also the computers we work on, because some of them can get really expensive. And it is much easier than you think to catastrophically damage them. So, basic terminology we need to kind of understand. A short, which a short is a sudden increase in flow that can create a sudden increase in temperature. Pretty much anything that has electricity flowing through it generates heat. Like if you have an electric heater in your house, that is essentially an intentional short causing the wires to heat up. That's all it really is. CPUs, they can heat up really fast. They can go from like room temperature to about 500 degrees in under 2 seconds. Once you push a lot of current through them or they're trying to process. All right, a volt, that is a unit of electricity. It is a measure of electrical force. And here in the US, the common value is about 110 to 115. In Europe and pretty much everywhere else in the world, it is 220 to 230. So in the US, when you plug something into the wall, it is receiving 110 to 115 volts. A watt is a unit of electricity that measures the use of the power consumption of a device. So when we're determining how much or what type of power supply we need to determine how many watts is required by all of the things we're going to be hooking up inside of our computer, and that'll tell us what type of power supply we need to install. And then you have capacitors, which a capacitor is basically something that holds on to electricity even after the device is turned off and unplugged. This is important for you to remember. Capacitors look like little batteries that are soldered down to the motherboards. And in the case of like a power supply, capacitors can be very dangerous. They can hold on to enough voltage to kill you. So for the purposes of the exam or what have you, even in life, there is never an instance where you will open up the power supply. It is in a enclosed metal box. You would just take the power supply out and put a new one in if there's an issue with it. Unless you are a certified electrician, you do not ever open a power supply. Only for time travel, Ryan. All right. So Just bear that in mind. And in order, before we work on a computer, we have to dispel the electricity that is stored in the capacitors. But we will talk about that here in a little bit. All right, transformers. These are devices that changes the ratio of the voltage to current so that it can be more usable and or not damage and destroy whatever devices we're trying to use. So basic terminology as we're going through. So protecting yourself from shock. Before you ever reach your hands inside of a computer, make sure it is turned off and unplugged. And then after you've unplugged it, you're going to press and hold the power button for at least 5 seconds, because what that'll do is dispel the residual energy stored in the capacitors to make it safe to work on. All right, so before the system is unplugged, do not ground yourself to the unit, because if you do, power can flow through you into the ground. Electricity is lazy. It travels on the path of least resistance, and we are easier to travel through. So until the system is unplugged, don't ground yourself to it. Power supplies, laser printers, CRT monitors. If you don't know what a CRT monitor is, congratulations, you're still young. The old CRT monitors, these are the really, really big ones that had a deep back. They weighed about, 600 pounds for a tiny monitor. People try to give these away for free because nobody wants to take them. But they have capacitors in them and can store enough electricity to be lethal. So these are the things, power supplies, high voltage power supplies and laser printers and CRT monitors. We do not work on these. They are what's called field replaceable units. You don't open them up, you swap them out. That's it. So PSUs in a computer, HV PSUs, which is high voltage power supply in a laser printer, and CRTs, field replaceable. Yes, it does. CRT does stand for cathode ray tube. All right. So stepping away from that for a minute. Fire extinguishers. Do I really need to know this? Yes, yes, you do. There are different classes of fire extinguishers. Class A, old school. This is basically a bucket with water in it and a pump. Pretty much just used for wood, paper, and other combustibles like that. Class B, this is used for flammable liquids like kerosene, gasoline, cooking oils, things like that. To B. A and B should never be used on a computer or any kind of computerized equipment. For that, we would use Class C, which is a non-conductive chemical, so it does not conduct electricity, and it puts out the fire that is caused by electricity. Most of the ones you'll see or interact with in an office are Class Cs, where they'll be what they call they're basically all three, but they're still Class C, so they're still capable of being used on a computer. And then the other one I think they use is called an argon one, which they're moving away from, because what that basically does is it displaces all the oxygen in a room. And it used to be used in data centers and server rooms and stuff like that. But the problem was if there was people in there, it didn't usually go over very well. So. All right. So in order to kind of protect ourselves, we need to be aware of what is called ESD, or electrostatic discharge. Anybody ever run around on the carpet, in the wintertime in their socks and they go touch the doorknob and it shocks them? Anybody ever do that just to annoy siblings? Oh, just me? Okay. But yeah, that's building up of static electricity. And here's the thing. If you can feel it, like feel that snap, that was at least 2,000 to 3,000 volts. Humans cannot feel anything below roughly 2,000 volts. We can't feel it, we don't recognize it. If you see the spark when you've touched the doorknob, that's at least 10,000 volts. It's kind of shocking, right? It's just, you know, right out of you, you know, like you're walking around on the carpet in the middle of winter and you reach out, you see that little spark, that's 10,000 volts. Now, components in a computer can be damaged and or destroyed with as little as 100 volts. So we can't feel anything less than 2,000, but you can fry a computer with 100. So we need to be very careful, especially when we're dealing with expensive pieces of equipment. You don't want to fry a $20,000 server, right? That's generally not a good one to explain to your boss. So it can usually cause two types of failure. There's catastrophic, which is really easy to guess. You know, basically the component's destroyed, doesn't work. Wonderful paperweight. And then there's intermittent or upset failure, which is the component works, but not very well. So this is gonna be a little bit harder to diagnose. So it may perform some functions okay and some functions not. The most sensitive to these would be like your motherboard, your RAM modules, your CPU, and you always want to make sure you're grounding yourself with what's called ESD equipment whenever you're interacting with these things. And you have 4 basic categories of ESD protection you can utilize. You have what's called the ESD bracelet, which looks like this. It's got a little alligator clip that you can clip onto the metal of the frame of the computer. Again, after it's been unplugged and all that kind of fun stuff. And then there's this little wristband that goes around your wrist. And there's a metal tab on it that just presses up against your skin. And it neutralizes the charge between you and the system you're working on. So there is no static discharge. Another way you can do this, they have ESD mats, grounding mats, that you can either stand on or have your systems working on. And then they have anti-static gloves, which if you've ever watched, you know, people take stuff apart and put together on YouTube, they're quite popular on that. They look almost like mechanics gloves, stuff like that. And they tend to be very useful for that sense for people who wear jewelry. Like we had a young lady in our class, she wore her wedding ring and she's like, I don't care, I'm not taking it off. And it was like, okay, you know, safety reasons I would, but she was like, that's fine, I'll wear gloves. And so that was her workaround. She's like, I am not taking it off, I'll wear gloves. And that's a workaround for it, if you want to do that. So that would be ESD gloves. Now there's another one here that's not really mentioned, but it's not for your personal grounding. This would be for grounding of servers, like inside the server room. And they have what are called grounding bars, and they attach to the racks that the servers are held on, and they ground out the servers so that you don't have ESD issues in the server room. Questions so far?
Yeah, question.
Yep.
So the casing around the casing for the console,
Mhm.
where the board is stored, is that casing mainly there to prevent ESD?
The casing around it, it actually serves multiple purposes. So yes, on the ESD, but it also protects it from shock damage. And it allows for more efficient cooling. So there's multiple reasons why you would keep it in a case. It's a good question though. I like that.
So when working on a laptop, would a ESD bracelet be pretty much useless?
I'm sorry, what was that again?
Working on a laptop, like say you're swapping out the RAM or the drive, would an ESD bracelet be useless in that situation?
No, it's still encouraged. The laptops become difficult because of the disconnect of the, disconnecting the battery because you still have the residual power of the battery. It used to be you could just clip the battery out and you were fine, but now the batteries are more embedded. But no, ESDs would not be useless, especially if you're interacting with the RAM chips and stuff like that, because you don't want to damage the component. Does it mean
So
you'll
what
do it
would you
every
attest-
time?
I was gonna ask, what would you attach the bracelet to then?
When you pop the bottom off, there's usually a metal piece you can clip onto. Before you would touch any of the internals. Because I know on a laptop, when you're swapping out RAM, it's just that little compartment you open up. But yeah, it's still encouraged to use an ESD, and you may get away with it, 99 times out of 100, not putting on an ESD and being just fine. But unfortunately, there's always that one time. And if it's on an expensive piece of equipment, or somebody else's equipment, you don't want to go having to explain that. Better safe than sorry, yes. Bashan, sessions are being recorded, so you will have access to the recordings. I will be creating a playlist on YouTube. Be sure to like, share, comment, subscribe. Gotta say it. We'll go viral with tens of views. All that fun stuff. But yeah, I'll create a playlist for you for the class, and you'll have access to older classes where you can go through and watch some of these subjects again if you need to. All right. So various ways to prevent ESD. Oh, sorry. Lastly, anti-static bags. These are like purplish, grayish bags that you receive components in, and they make it so that ESD cannot transfer through the bag. So whenever you're transporting or storing components, you want to keep them in some form of anti-static bag. What I usually do is after the first few components that I've purchased, I just saved the static bags that those things came in, and I just fold them up. They're like small Ziploc bags, and I fold them up and I just keep them in my tool bag. So if ever there's a case where I need one and I don't have one, I can just pull one out and throw it in there and use it, and I don't have to buy anything extra. They usually come with the component anyway. You got one, Justin? Handy?
Yeah, I do. Give me 1 second.
I think so. Oh, shoot.
No? For a second.
Oh.
Just
nah,
one.
don't. Is it in here? Oh. Here we go.
There you go.
You can see it. Oh, the blur. Hold on. Oh.
Never mix blur with blur.
Yeah. See the blur. All right. It's like this.
There you go. So it's like a metallic, purplish, grayish looking bag. And then just don't toss them when you get done, and just keep them in your tool bag. And they can come in handy. Thank you, Justin. All right, let me check. There it is. So that's ESD. All right, basic protocols when you're working with others. If you're going to pass a component from one person to the next, before you hand the component over, reach out and just kind of lightly touch them on the arm or the shoulder or whatever, because that'll neutralize the charge between the two of you, because it's going to be the first point of contact. And then you can hand them the component, they can grab it without running the risk of destroying the component. Store the components in anti-static bags until you're ready to use them. Just address that. Try to work on hard floors, not carpet. Carpet is pretty bad about building up static charges on your shoes, as because we tend to shuffle our feet, stuff like that. So if the area you're in is carpeted, try to get an anti-static mat to stand on. Humidity. Humidity is a big issue with computers. And they like it not too humid and not too dry. So for the case purposes of this particular technical session, why we do not want it dry is why I use the scenario of in the winter up north. That's because it's usually when you're running your heat a lot. And when you run your heat a lot, it drops the moisture in the air drastically. When you do that, that is why you start having the static electricity. So you want a relative humidity of about 50% when working on computers. It's not too much, it's not too little, and it'll minimize the buildup of static electricity. If you received a component in the mail, take it out of the box in another room or another area. Do not do this at your work area, because they don't really do it so much anymore, but they used to fill up these boxes with styrofoam peanuts. Styrofoam peanuts are absolutely horrible about static electricity. You ever go in and the styrofoam stick into your arm, into the sides of the box and all that stuff? That's all static electricity. So a box of styrofoam peanuts is like a nightmare for any kind of computer component. So if the box you're opening up has all that in it, do it in another room. Just keep it safe. That way you don't damage the nice, fancy, brand new components you just purchased. If you have long hair, not a problem for me. Tie it back. You don't want it falling down into the computer. Remove any loose jewelry. Jewelry can create a short between two pieces. If the jewelry falls in there and it crosses over two components or two welds, it can create a short, damaging the unit. All right, any questions on that? Yeah, that would be horrible, Justin. Did you do that? Yeah. One of the TAs I started out with, he and I started together. He put the CPU and then the cooling, he put everything in and didn't use thermal paste, which basically means it can't transfer he can't transfer heat very efficiently, and he nuked his CPU, like brand new computer he built. He never forgot again. All right, so some tools that you're going to likely have in your tool bag if you're working on site with a company. You can get a basic toolkit for $20, something along those lines. They're not very expensive. And it comes like this one here is a basic, basic kit. I worked with one of the kit that looks exactly like this when I was in the cohort. It comes with a grounding bracelet, you can see right here. Various bits to work on. You have a organizer box here for screws that you pull out. And then you have a screwdriver, non-magnetic. Magnetic screwdrivers are really bad for working with electronics. And unfortunately, some kits will put them in anyway. Got needle nose pliers. And then there's a fun piece right here. Looks like a little horseshoe like this. And then it's got these little hooks on it. Like that. This is called a chip extractor. A lot of people go like, nah, I don't need it. It's just a waste of time. I got stuff to do. I can do this without that. They'll just reach in, grab that chip, go ahead and move it where they want to go. Cautionary tale. When I was a student, they had a TA come in and they were going to do a build out on a computer and kind of show us how it's done and kind of how all the stuff goes together. It was really cool. Well, this TA, like many of us, was nervous talking in front of groups of people. And they were installing a AMD chip onto a motherboard. And why that is important is an AMD chip has pins that stick out of the bottom of the chip, hundreds of them, and they're about the size of a human hair. And these chips go into little ports in the motherboard, and that's how they communicate. The TA picked up the chip with his bare hands rather than using the chip extractor. And as he was moving from the box where the chip came in to the motherboard, got nervous and dropped the chip. And the chip fell, bang, right on the side of the computer. Barely tapped it, but it bent like 30 of the pins. All because didn't want to use chip extractor. So take the time. It's a 50-cent piece of equipment. So rather than go without it or not use it, you can damage a several $100 processor. And if those pins on the bottom of that CPU break, CPU is useless. We were able to, I had a precision kit in my car with a magnifying glass, and we were able to, over the course of an hour, bend the 20 or 30 pins back into place and actually got it to work. But that's not always the case. So be sure to use it. All right. Post diagnostics cards. These you won't see very often. Newer motherboards actually have these post readouts right on the motherboard, which is pretty cool. And what POST stands for is Power On Self-Test. What it's doing is the BIOS, or the UEFI, which is a upgraded version of the BIOS, is running a series of tests, making sure the RAM's okay, there's hard drives connected, CPU's fine. And so it runs through these series of tests and making sure that the basic stuff is working before it goes and talks to the operating system. If something is wrong, you will get a series of beeps and the system won't turn on. Has anybody ever had this happen where they turn on their computer and it starts to boot and it just goes beep, 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 and then stops? I will be sharing the recording, Ravina. I'm recording it right now. So that's a post error. And there's a couple ways we can determine what it is. Newer motherboards have the readout so that you can actually see it. The postcard will give you an actual code that you can look up and see what the error is. Or you can go online and said, I had 3 short beeps and a long beep, and it was a, whatever brand of motherboard, and it'll tell you what the error is. So you can actually Google it. But the general rule is if you just opened up that computer and you were messing with something, that's probably what the problem is. So if you were adding RAM or moving RAM around or whatever, you probably didn't fully seat the RAM. So general rule on that. But if you don't know, you can always go in, look it up, Google it, and it'll tell you exactly what the error means. So it'll give you an idea as to where you need to troubleshoot. That's POST, Power On Self-Test. Other fun tools. We have one here, it's called a crimper. And you see these 2 little holes here. This would be for an old school phone line and a new network card. So once you have threaded the 4 to 8 wires into the little clear plastic clip that you clip into the wall of your computer, you would use this crimper to clamp things down, and it'll push these little copper blades into the wires so that they can actually communicate. It's called a crimper. Cable stripper. They have one built into this crimper. It's this little razor blade right here, and it allows you to cut the plastic sheathing off of the cable so that you can access the wires inside. Multimeter looks like this. It's good for testing your PSUs or various units to make sure they're getting the appropriate level of voltage they need to function. It's usually just a box with a red and black wire attached to it. They don't have one here, but I'll show you one here in a little bit. And it's called a tone generator and probe. And what it does is you plug one end into a computer. Say you have a big server room with 100 wires coming into the switch, and the IT professional that was there before you did not properly label. Do you want to go start randomly unplugging things to see if it's the right one? I would hope not. So a way we can kind of figure this out is what's called a tone generator in probe. The other name that they like to call it, which is an old school electrician's term, is called a fox and hound. The tone generator sends a musical tone through the wire, and then you go into the server room and it has a little probe and you touch each wire, and when you hit the right one, you'll hear a musical tone come out. The only time this doesn't work is if it goes through a switch. A switch eats the tone. So once it goes into the switch, it won't come out. So you have to catch it before then. That's a tone generator and probe. Then you have this piece right here, which is two pieces that kind of clip together. This is called a cable tester. You would take it apart. You can either, I think it's like 300 meters. It can work apart. And what you do is you plug one end of a cable in one side, one end of a cable in the other, and it sends a pulse down each wire in the cable. So a network cable has 8 wires. It will send a pulse down each one and make sure and tell you, like on one end it's transmitting, one end it's receiving. So if it'll go 1, 1, 2, 2, 2, 3, 4, 4, and it'll let you know if the cable's good. If it's a different type of cable, because you have what are called straight through cables, you have what are called crossover cables and rollover cables. If you plug them in on each side, like a rollover, it'll be like 1, 8, 2, 7, 3, 6, because it flips them. So you'll know you have the wrong type of cable for what you're doing. So cable testers are very useful in that sense. We will talk about these again. You don't have to memorize it all now, just kind of giving you an introduction to each of them. A loop back plug, you'll hear this one a lot. It's just a little, looks like a nub of a Ethernet cable, like with no wire. I have a better version of this I'll show you later, but what it's doing is it's taking the outbound wires of your internet and then looping it right back into the inbound wires of your internet. What it does is it tests your network card to make sure it's functioning. So you plug it in and it's just pulsing and cycling that pulse, and then you'll just see the network card light flashing. If it's flashing, you know it's working. So it's just a quick, easy test just to make sure things are working. That's it. But I'll show you one here in a little bit. Punch down tool looks like this. And this is used for creating the ports in the wall where you plug the cables into, or the punch down block in the server room, so that you can take the horizontal runs out of the walls and then set them up to be able to hook into the switches and stuff like that. I have a video on them using a punch down block and all that kind of fun stuff. So we will look at that one again. And what it is it's kind of like a horseshoe shaped item, almost like your chip extractor that we were looking at earlier. So the end of the tool, like right here, it's like round on one side, and then the other side is a knife like that. And what it's going to do is one side pushes the wire in, the other side cuts the wire off flush so it looks nice and pretty. And that's basically what a punch down tool does. But again, I have a video on punch down tools. I'll show you one in action. You'll have a better idea of it a little bit later. And lastly, Wi-Fi analyzer. All this really does is let you know what Wi-Fi signals are in the area. So your phone can be turned into a Wi-Fi analyzer. There's applications you can download to turn your phone into that, and it'll show you all the Wi-Fi hotspots in the area, even the ones where they don't broadcast. It'll tell you, you'll know they're there. You know, and it'll tell you the signal strength and all that stuff, so you can map out the area. As a tech, you would do this to kind of see what channels are being used so that you can better lay out your Wi-Fi antennas and stuff in the office. Questions so far? These are just some of the basic tools we'll be interacting with. And a lot of this stuff we're going to be going over again, so don't worry. All right. With that,
Question, do we
yes.
have to have those tools, or is the job place usually provide that for you?
If you're on site, a lot of times they will do it for you. They'll provide them for you. If you're doing the piecemeal work, like I was talking about Field Nation or whatnot, you would have to provide your own tools. If you're working remotely, you likely won't need them. So it depends on your job. And you know, the kit that they're going to give you at your office may not be that great. You may like a nicer one for yourself, depending on how often you're using it. You know, so like if you have a little bit of arthritis in your hands, holding onto small screwdrivers is painful for any length of time. So you may want one with like a fatter knob on it so that it's easier for you to work with. So, you know, you may want to buy your own kits depending on your situation, but again, a lot of places will provide them for you, and they tend to be inexpensive. Like the ones I showed you earlier was like a $20 kit on Amazon.
These tools, it sound like good things to have at home for like personal use. Yeah.
Mm-hmm. I ended up getting like one of my, I have an electronic kit. I'll see if I can find it and show y'all. And it is my most used toolkit of anything I have. Basically any kind of electronics device or whatever, I just break it open and I have almost everything I need in there. Having young ones who have items with batteries that constantly need replacing, stuff like that, and they always make it so that those battery compartments can't be opened without screwdrivers, works great. But yeah, you are absolutely correct, Andrew. All right, so now we should be able to, at a high level, describe kind of how computers work, including, you know, the interaction and relationship between software and hardware and firmware. Talk about some key safety precautions and tools that we would use. With that, open it up. Questions, comments, concerns, complaints, revelations. First technical session down.